Hey everybody, I hope you guys are doing well and your studies for your AP's test coming up is going fantastic. So this quick free response one is an example of how to use a binomial probability, and so we're going to show you how to do this on a TI calculator. So here we go. So it's difficult to distinguish between apples and onions by taste alone if one is not allowed to smell. Yes, that says apples and onions. A person claims that he can distinguish between the two. And so the following test is designed. He will be given a sample of each in random order to taste while being blindfolded with his nose pinched. This will be repeated 15 times. So let P be the proportion of times that he answers correctly. So what are the null and alternative hypotheses? Okay, so the null and alternative hypotheses are this, you guys. If he can't distinguish and he's just randomly guessing, you guys, and we would say, you know, that the null hypothesis is that, well, half the time he's going to get it correct and half the time he isn't. If he's randomly guessing, you guys, it's like flipping a coin. It'd be 50-50. So he's predicting that he can guess more than 50-50. So the alternative would be P is greater than 0.5. Okay, so the null is P is equal to 0.5, and the alternative is greater than. Okay. So part B says, suppose he answers 11 out of the 15 trials. So he answers correctly 11 times out of the 15 trials. What is the probability of answering exactly, notice I underlined exactly, 11 of the 15 if he were simply guessing? Okay, exactly is a binomial PDF. You're just finding the probability at exactly 11, you guys. So you're going to use the binomial PDF function on your calculator, and that's located in your distribution function on the TI. So your distribution is in that second function var. So then scroll down to 0, which is under number 9, and then under that is binomial CDF. So underneath binomial PDF is binomial CDF, and we'll talk about that in just a second. But this one's a binomial PDF because of the word exactly. So then you're going to punch in binomial PDF and 15 trials, 50%, and then exactly 11, and so we're going to get a little bit more than 4%. So answer it in the context of the problem. So I would say something like the probability of answering exactly 11 of the 15 if he were simply guessing would be a little bit more than 4%, something like that. Okay. Let's see. So what is the p-value if he answers 11 of 15 and then interprets this in the context? Well, remember, you guys, he thinks he should be getting greater than 50% of the time, and so he got 11 out of 15. So he's interpreting greater than. So we're looking for the probability that x is greater than or equal to 11. Okay. So if it's greater than or equal to 11. Remember, it's a success sort of fail thing. That's what binomial means. You either win or lose, or it's on or off, or it's left or right. There's only two choices. So you know, he either gets it correct or he doesn't get it correct. So so the binomial PDF, I'm sorry, this is a binomial CDF. If it's greater than or equal to 11, I tell my students it's like the complement of that. The complement of that would be 1 minus that, because you know it's 100% totally. So our calculator, our CDF calculator, C means cumulative. So it means the numbers plus the number below it. So if I did binomial CDF of 10, it would be, you know, the binomial CDF of 10 plus 9 plus 8 plus 7 all the way down to 3, 2, 1. So 1 minus that would get me the rest of it. So this is 0.05923. That would be 1 minus that, and that would equal that it's greater than or equal to 11. So if he were guessing, the probability of getting a result this extreme, 11 or more correct out of 15, is 0.05923, which is, you know, not quite 6%, but it's over 5% right there. So is there sufficient evidence to reject the null hypotheses and give the answer in the context right here? Okay, so since they didn't state, you know, at the 5% level or the 10% level, let's just, you know, include them both in our answer right here and say something like, you know, with your probability being 0.05923, you could say something like there's sufficient evidence at the 10% level, but it's not at the 5% level to reject your null hypotheses and conclude that he was simply not guessing. Okay? Okay. Hey, if you're finding these videos helpful for your studies, just click like. That would be cool, you guys. Take care.